So, multiplication of vector, there are two parts of the multiplication. One, when we are multiplying two vector quantity, then sometime we are getting scalar quantity, and when we are multiplying two vectors, then we are getting vector itself. So, that in that basis we can define multiplication of vector in two categories. There are two types of multiplication of vector. Multiplication of vectors. One is called scalar multiplication, and another is called vector multiplication. Vector multiplication. So, see the meaning of this separately. First is your scalar multiplication. Scalar multiplication, or it is also known as scalar product or scalar product. So, according to this, when on multiplication of two vector quantity, when on multiplication of two vector quantity, two vector quantities, if we are getting scalar quantity, then that type of multiplication is called, that type of multiplication is called scalar multiplication. Scalar multiplication. So, for it means if A and B are two vector quantities, making an angle theta, then their scalar product is defined as R is equal to your A dot B, or it is written as mod A mod B cos theta. So, either in this form we can write or that form. So, this is the called your scalar product. So, from here we can get the theta also, cos theta your vector R by mod A or mod B, or R can be written as here A dot B by mod A mod B. In this manner we can get the value of cos theta also. So, examples of scalar product. Example, see, work done, work done. As we know, multiplication of force and displacement gives a vector. Multiplication of force and displacement. So, multiplication of force and displacement give us work done. Work done is scalar, while force and displacement are vectors. Similarly, another example we can say power. Power, this is also the multiplication of force and velocity. This is also one of the example of your dot product, or it is also called scalar multiplication. So, scalar multiplication, it is also written as, so it is also defined as, it is also called as dot product. It is also defined as a dot product. So, see the some of the application of your dot product or scalar multiplication. Now, scalar product or dot product in orthogonal unit vector form. In orthogonal unit vectors, see, as dot product is written as, dot product R is written as A dot B or mod A mod B cos theta. So, in orthogonal unit vector, in orthogonal unit vectors, in orthogonal unit vectors, I, J and K are mutually perpendicular. I, J and K are mutually perpendicular. So, see here. So, when we are doing I dot J in orthogonal unit vectors, I dot J means modulus of I, modulus of B, and cos theta means angle between I and J. Angle between I and J is your 0. So, I dot J is your 0. Similarly, I dot K is also 0, because again angle between I and K is 0, and J cross I, it means any two pair of unit vectors, their dot product will be 0. So, from here we can say I dot J is equal to I dot K is equal to J dot K, all will be here 0. But if we are multiplying same vector means, same vector means here, let I dot I. So, in case of I dot I, magnitude of I is your 1, magnitude of B same vector, that is also 1, theta. Both are the parallel vectors, angle between them is 0. So, cos 0 your 1. So, I dot I will be your 1. Similarly, J dot J is also 1 and K dot K is also 1. So, dot product of the similar vectors in orthogonal unit vectors will be your 1, and dot product of the dissimilar vector. In orthogonal unit vector is always 0. So, this point we have to remember while we are solving such a problem. See one of the example here. Now, see one example of scalar multiplication. A particle is displaced from position R1 is 2i plus 3j minus k meter to R2 is 6i minus j plus 3k meter under a force F is equal to 2i cap plus 3j cap plus 4k cap Newton. Find the work done by the force on particle. Now, see the how to solve this one. So, work done can be written as work done W is here F into R and force into displacement here, and F is nothing whatever the force acting here, R is the displacement. Initial position of particle was your R1, final position of particle your R2. So, R is written as R2 minus R1. So, now substitute the value of F and all these value. F is here 2i plus 3j plus 4k cap, 2i plus 3j plus 4k cap dot R2, R2 6i minus j plus 3k, 6i minus j plus 3k minus of R1. R1 here 2i plus 3j minus k. Now, we can simplify 2i plus 3j plus 4k dot 6i minus 2i 4i minus j minus 3j minus 4j 3k plus k 4k cap. Now, do the dot product. I and I will multiply. 2 into 4 will be 8, 3 and minus 4 minus 12, 4 and 4 plus 16. So, finally, we will have answer is your 12 joule. This is the work done. So, work done by the force by this dot product we can determine like this. Similarly, see another example. A particle is moving with velocity v is equal to 2i plus 3j minus k meter per second, and it has acceleration a is equal to xi cap plus 2j cap plus 4k cap meter per second square. Question is that if at this instant if at this instant velocity of particle, velocity and acceleration of particle is mutually perpendicular, then find the value of x. Then find the value of x. This is the problem. Now, this is the question here. Velocity and acceleration of particle are given and they are asking if these two are perpendicular. So, what is the value of this? It means V and A are mutually perpendicular. So, we can say theta is here 90 degree. So, as per the dot product, as we know, whenever two vectors making an angle 90 degree, so or if we are doing V dot A, so we will get mod V mod A cos theta. Now, if theta is 90 degree, so their dot product will be always 0. So, as theta here 90 degree, so that give us V dot A is equal to 0. So, V dot A is 0. So, what we will do? We will do the dot product of velocity and acceleration and make it equal to 0. So, V dot A, see, V dot A means same coefficient we will multiply, I and I multiply 2x, then j and j 3 and 2 6, and then k 4 and minus k minus 4, which is 0 here. So, this give us 2x is equal to minus 2, x is equal to minus 1. Likewise, we can solve this problem. So, this is the just small application of your scalar product. Now, come to the vector multiplication, and that is also called cross product. Next is the vector multiplication. So, when the product of two vector quantity, when the product of two vector quantity is another vector, then it is called vector multiplication. Then it is called vector multiplication. Or cross product, it is defined as, it is expressed as, let A and B are two vector quantity, vector quantities, and their product is also vector, and their product is also vector R. So, R is written as A cross B. So, since we are using cross symbol, that is called your cross product. Now, This further we can see vector r, mod of A, mod of B, sin theta, then we can use here n cap, where theta is the angle between vector A and B, and n cap is unit vector which represent direction of vector r, direction of vector r. This is the meaning of cross product. So, first of all, how to determine the direction of vector r, and how to get the magnitude of vector r. See here, for direction of vector r in cross product, it means r is, as we have written over there, A cross B. This is nothing, mod A, mod B, sin theta n cap. It means here we are having two vectorlet A and B, and this is the angle between these two vectors. So, for direction, what we will use? We will use, for direction, use right hand thumb rule. Use right hand thumb rule. So, what is that rule here? Stretch your right hand finger and thumb in such a manner the fingers are moving from vector A to B. As we are finding r equal to A to B, the fingers are moving from A to B. It means A to B like this. Then thumb gives the direction of vector r. So, you can write here, stretch right hand fingers and thumb mutually perpendicular if fingers are rotating in the direction of vector A to B, in the direction of vector A to B, then thumb direction gives the direction of vector r. See, according to the right hand thumb rule, since we are finding r is equal to A cross B, so A cross B, it means we have to move from A to B. So, when we are moving from A to B, according to right hand thumb rule, just stretch your finger from A to B. So, A to B, then where is the thumb? Thumb your outward. So, that outward gives the direction of vector r. So, here we can use a dot. Dot gives the direction of vector r. Similarly, if we want, suppose B cross A. Similarly, see, if we want, let r dash another vector which is your b cross a. Our a and b are in the same direction. A and b are same direction, but here our aim is determination of b cross a. So, b cross a means our finger should be from b to a. If the fingers are from b to a like this, so where is the thumb? Thumb is your inward. So, that inward means you can say here cross. The cross gives the direction of vector r. So, in this manner we can determine the direction of vector r. It's a cross b. So, you have to go from a to b, b cross a, then you have to go from b cross a. So, from here it is clear we cannot say a cross b and b cross a are the same, although their magnitude will be the same, but direction are different. So, whenever any two vectors which are having even same magnitude, but if directions are different, so those two vectors are not called as a same vector. So, okay, these two may be your anti-parallel vectors or opposite vectors. So, see how we can use this vector cross product in case of orthogonal unit vectors. See, now vector cross product, in for orthogonal unit vectors. Orthogonal unit vectors. See, orthogonal unit vectors means we are having I, j and k cap. These are three orthogonal unit vectors, I, j and k, and all these three are mutually perpendicular. As per the cross product rule, r is your a cross b, which is equal to your mod a mod b sin theta and n cap. N cap gives the direction. See, same thing. If we are looking I cross I means mod of I, but sine. These are the same vector. So, angle between this is always 0, this is 0. So, we can say I cross I 0. Similarly, j cross j will be also 0 and k cross k also 0 here. It means same vectors, whenever we are making their cross product, their result will be 0. But when we are considering, let I cross j. So, I cross j, see, this is your I direction, this is your j and k is this. It means we have to go from I to j by using right hand thumb rule. So, right hand thumb rule here, direction here along k cap. Direction is along k cap. So, we can write here mod I cap, mod j cap, direction your k cap. Since I and j have unit vectors, their magnitude here 1. So, finally, we are getting I cross j is your k cap. Similarly, then j cross I, as I said, these two are opposite direction. So, j cross I will be your minus k cap. Now, if we are looking j cross k, so j cross k means here this is your j and this is your k. See, this is your j, this is your k. K is means this. So, we have to go like that. If our finger is going from j to k, then it comes here towards I. So, j cross I is your mod of j, mod of k cap, and direction comes here I cap. So, finally, we can say j cap cross k cap is equal to your I cap. So, reverse of that, and k cap cross j cap here minus I cap. Now next is your, we can say k cross I. K cross I, this is your k, this is your k, this is your I. We have to move from I to k. I to k means like that, then it comes your j. So k cross I is your again mod k cap, mod I cap, and direction here comes j cap. So we can say this is your nothing j cap vector. So I cross k is your minus j. So for simplicity we can make like this. We can say let this your I cap, this is your j cap, this is your k cap. So when we are moving like this, I cross j, then it become your k, and j cross k. See, I cross j, you will get I cross j, you will get k, j cross k, you will get I. So I cross j, you will get k, j cross k, you will get I, then j cross I, you will get j. Reverse, when you are moving in that side, minus k, in this side minus I, and this side minus j, like that. So for simplicity, for remember, you can make here I, j and k. So I cross j will k, j cross k I, and k cross I j. And similarly, if you are going reverse side, in I cross k minus j, k cross j minus I, j cross I minus k. So in this manner we can solve the dot product, cross product in case of orthogonal unit vector. See one or two example, from that we can get better idea. Let vector A is axi cap plus ayj cap plus azk cap, and vector B is given as bxi cap plus byj cap plus bzk cap. And if we want to make cross product, then A cross B can be written like this: axi cap, ayj cap, azk cap cross bxi cap, byj cap and bzk cap. Now see how to do cross product. So first we will make cross product between axi cap with the whole three these vectors, then j from all these three, then k again all these three. See, as we know, same type of unit vectors give zero cross product. Axi cap cross bxi cap will be 0. So what is left now from here? Ax by and I cross j, that will be your k cap. Similarly, axi with a k, so I cross k minus j, so minus ax bz j cap. So this is the first expression from here. Now from this ayj, j cross I, ay j cross I is your minus k, so minus ay bx k cap, j cross j 0, j cross k I, ay bz I cap, like this. Then for this k, in this k, az bx, k cross I j, AZ BX J cap. K cross J will be here minus I, minus AZ minus AZ BZ so AZ BX is your I, AZ BY I cap. K cross J is here minus I. Now, from here we can take I and I together. From here AYBZ minus AZ BY I cap, then J. Here J this, here J this, plus AZBX minus AX BZ J cap, then K we can take together. Here K AX BY, here minus AY BX AX BY minus AY BX K cap. So, in fact, this is the answer of A cross B. So, A cross B can be expressed in this form. See, one more easy method of finding A cross B is your determinant method. In the determinant method, A and B are these two vectors, I, J and K are their unit vectors. So, first write down the I, J and K and then their corresponding coefficient. A cross B, to first write the coefficient of A, AX, AY, AZ. Then write the coefficient of B, BX, BY, BZ, and this determinant we can solve. How we are solving? I, first I, so just leave this row and column, then whatever left cross multiply this. So, this is equal to your I, cross multiply this AY BZ minus of AZ BY, AY BZ minus of AZ BY. Now, come to the next here. Next here J. J you can have J, so leave this column and this ray. So, whatever left here, since we are going from that in the same sequence, the AZ BX minus AX BZ, the AZ BX plus J, AZ BX, then minus AX BZ minus AX BZ, then come to the K. When we are looking to the K, leave this and this, then what is left? AX BY minus AY BX, AX BY minus AY. So, this is also one of the method. The A cross B, either you can go with this or by using determinant method we can determine the value of A cross B. So, see the one or two example based on the vector cross product. If force F is equal to 2I plus 3J minus 4K is acting on a particle at position minus I cap minus j cap plus 3 cap meter. Find the torque on a particle about origin. So, this we have to find. See how to solve that one. As we know, torque tau is defined as R cross F. So, substitute the value of here, the torque. Directly we can use IJK vector form here. R means minus 1, 3 coefficient, minus 1, 3. F 2, 3 minus 4, 2, 3 minus 4. This is the meaning of torque. Then we will simplify. First take I common, this into this minus this into this, minus 1 minus 4, 4 minus 9, 4 minus 9 plus j. Next j from here to here, 3 into 2, 6 minus 4 into 1, 1, 6 minus 4 this plus k cap. So, k cap, so minus 1 into 3, minus 3, minus 3, minus of minus 2. So, that become your plus 2. Finally, we will have minus 5i, this is your plus 2j and minus k. This is the net torque. So, torque on a particle is given as minus 5i plus 2j minus k. This is the way by which we are calculating torque. In this manner, we can do the vector multiplication and scalar multiplication.